The Weather Alert Project 21 was an effort to originate, to relay, and to deliver alert messages from the National Weather Service by amateur radio. What did we learn? Watch this episode of Radio KD8TTE to find out.
SWAN.
We've heard it said many times, and we might have said it ourselves, that amateur radio can save lives in an emergency. So we have seen, in many cases, communities have actually built amateur radio operators into their plans for responding to emergencies and to disasters. Emergencies, of course, can take on many different things. It might be a flood, it might be a tornado, whatever it is, it damages infrastructure, and in addition to having an impact on the community, is going to have an impact on the communication infrastructure that emergency responders need to be able to save lives and to save property. We started taking a look at where amateur radio can play a role in these kinds of situations, and we have some examples that we can point to today. Of course, the National Weather Service has its SKYWARN program, where trained spotters are able to watch what's happening and can report ground truth to the National Weather Service. That raw intelligence can be combined with information that comes in via radar and via satellite to be able to build a complete picture of what's actually happening on the ground to create better quality information products and to be able to serve the communities better. We also have in Ohio a program where amateur radio operators not only are reporting to the National Weather Service, but those who do not have reports to give themselves may listen on those SKYWARN nets, can copy those reports by intercept, and send that raw intelligence on a separate channel up to the Ohio EMA Watch Office. The Ohio EMA Watch Office is very interested in having this kind of information, and of course they will see the National Weather Service alerts as they come out. However, with 5 different forecast offices covering the state of Ohio, it's going to take time for that information to be collected, to be synthesized, and to be released. The Ohio EMA Watch Office is interested in raw reports as well. So this intelligence coming from the field, being relayed by amateur radio to the W8SGT station at the Ohio EMA, is able to give the Watch Office a little bit of heads up about what's going on, and then that information can of course be filled out more completely when the National Weather Service alert follows, maybe a few minutes later. In both of these scenarios, we're talking about volunteers getting information to agencies. But there is a question. How would we get emergency information from the National Weather Service to local emergency managers and into the communities where they need it if the infrastructure has been compromised? Today we have a couple of options for how those alerts can get out. That's going to include the emergency alert system, which you'll hear on commercial television and radio. There's the wireless emergency alerts that will come on cell phones and so on. And of course, there's the NOAA all hazards radio, the weather radio that we hear. And that's going to be 3 different ways that we're able to get that information to an affected community. Now, of course, why would we want to get information out over all of these pathways? Well, the fact is that no system is going to be 100%, and so it doesn't necessarily make sense for us to put all of our eggs in the basket of the NOAA weather radio, because not all the transmitters are going to be working all the time. Just like anything else, they're going to need maintenance. Some of them are going to have to be taken out of service. They may be damaged in some kind of a storm. Any of those things can happen, and that's the reason why it makes sense for us to have multiple pathways. Of course, being able to use multiple pathways doesn't mean that we're necessarily able to get the alerts out over those multiple pathways. That can be difficult. That's the reason why we have the IPAWS system, the Integrated Public Alert and Warning System. It transmits alerts over multiple pathways at once, and the idea is that an agency, an alerting authority, may issue an alert using a standard method, the Common Alerting Protocol, issue that alert, inject it into IPAWS, and then IPAWS will take care of the necessary routing and get it to the distribution pathways so that all of the necessary systems will be able to fire up and get that alert message to the greatest number of people in the least amount of time. This is a fantastic system. The issue that we have when we're dealing with any kind of a disaster scenario is, of course, what happens if we have an alert that needs to follow an F5 that's already blown through and knocked out infrastructure. As it turns out, IPAWS is dependent on the internet to make this work. So if we have an alert that follows a wave of storms, for example, it might not be possible for an alerting authority to get that message injected into IPAWS, or for IPAWS to be able to get the message to the local distribution means to be able to get that tower to fire up and send out those alerts to cell phones, to be able to get that NOAA all hazards transmitter to be able to send the message, or to be able to get the local broadcasters to issue the alert over television and radio. The Black Swan 20 exercise tested for the first time the ability to get an alert message from IPAWS to local distribution methods without using the internet. We did it strictly by radio, and that was the first time it had ever been done. We were able to show that it is possible, but we've got some work to do before it's going to be viable. The model that we used for making that work was one that we had tested out in the County Information Report Project 20. We've talked about that in other videos, so we'll recap it only quickly here. The idea is that we have somebody in a position of an alerting authority at the state level or the section level, as we look at it in the structure of the American Radio Relay League. Somebody at the state issues a message that then gets distributed to each of the 10 districts that make up the Ohio section. Those districts were the way that the Amateur Radio Emergency Service in Ohio is organized, and then each district further distributes down to the counties. The counties may then distribute to the necessary officials within the county. The County Information Report Project 20 demonstrated the concept of layers of networks for reliable message relay. We were able then to put it to use in Black Swan 20. The same concept was used again for the Weather Alert Project 21, except that instead of a single messaging authority like the state EMA, we now have 6. That's the 5 local NWS offices plus the Storm Prediction Center in Norman, Oklahoma, which also issues alerts for Ohio. This network design is flexible and scalable. It can be used where many localities need to message just a couple of critical sites, for example, in poison centers. We have 2 poison centers that cover the state of Ohio. Cincinnati covers northeast and southwest Ohio, and Columbus covers the rest of the state, about 2/3 of the area. A healthcare provider in Cuyahoga County, up in northeast Ohio, would need to contact the poison center in Cincinnati in southwest Ohio for a consultation. What this demonstrates is that we have different needs from different agencies, and if we are going to be able to provide an effective and viable service for our communities with amateur radio, we need to be able to adapt to the needs of that agency, of that community. Returning to the Weather Alert Project 21, let's take a look at the roles that need to be played. We have transmit stations. Those will represent a message originator, some alerting authority. The Weather Alert Project 21 transmit stations cover National Weather Service offices, for example, in northern Indiana, which covers northwest Ohio, Cleveland, which covers northern Ohio, Pittsburgh, which covers eastern Ohio, Charleston, which covers southeast Ohio, Wilmington, which covers west and central Ohio, and then, of course, the Storm Prediction Center from Norman, Oklahoma can also inject messages. Our receive stations in this design are going to represent an agency that would use the alerts, a local emergency manager or a disaster relief organization. The tools that we have are for message origination. We have a piece of software called Get Alerts that retrieves these common alert protocol messages from alerts.weather.gov to simulate being at an alerting facility. So if you're at the alerting facility, they've got an alert to send, they create it, it's going to be in that CAP message format, and then now you've got it as a radio station. That's what we're simulating in this case. Another piece of software, KD8TTE, takes a CAP alert and originates a basic message, the so-called 16-line message for transmission. The basic message, as used in government and military, is a good radiogram format that helps us to solve a large number of problems that we have in message relay. Our software, KD8TTE, includes routing from state to district to county in the ARRL field organization for 11 states presently. The Black Swan net is a multi-mode, that is voice control and digital relay net. We use FLAMP then to transmit those messages. The transmitting station will send to the stations representing the areas covered by the alert. The receiving stations will then send the reports of reception so that any of the blocks, any parts of the message that they did not receive and confirm can be retransmitted. It's much better than retransmitting the whole message, and it also allows for other stations to relay missing blocks in the event that that's necessary. Message delivery is something that we're simulating by using Winlink. The received message can be compared against the sent message to confirm that it's 100% accurate, so the CAP message is intact and can be processed just as it would need to be at the point of message distribution. The relay time can also be measured to see whether the quality of service that we want to offer is actually being met. For message processing, that is what is going to be on the receiving end, we don't actually have a tool for that yet. We're thinking maybe it would make sense for us to do something that would get the message and then automatically log it in a central place where we can make some comparisons rather than manually having to build up the quality of service analysis. We should be able to do some fun stuff with it as well, maybe sound some kind of an alarm on the receiving end if that's in fact the right thing to do for that type of message. What are the results of our Weather Alert Project 21? Well, by the numbers, we started in May 2021 with one state. Today, we've got over 43,000 messages that have been originated. We are covering 11 states. We are handling the quality of service necessary by implementing the message precedence that the radiogram will support. As a proof of concept, we've been able to see that it does work. We're able to see that we are able to hit our quality metrics when we're moving messages through the system, and we can do so very often, but not all the time. We do need some help to make this system viable. So some future work, the Weather Alert Project 22. Well, we're looking at the question of message routing. Right now, we're based on the model of amateur radio stations in the ARRL field organization. That is the section going down to the district, going down to the county, going down to the individual or the agencies within that county. The model works if the operators are there, but our participation from ARES stations in Ohio has been generally poor. The operator interest is limited. Maybe it would be improved if served agencies were specifically asking for it. Some have some technical difficulties. For example, during daytime operation, we need to use 5 megahertz to be able to communicate effectively in state, and not everybody has the gear that's going to work on 5 megahertz. An alternative in our routing could follow a structure that would be built around an AUXCOM, an auxiliary communication function that would belong in the emergency management world. The design of statewide net operations around Ohio could be around the EMA models of the regions inside of a state and counties inside of regions. The model of message routing doesn't need to match any agency or community's idea of administrative boundaries, but it might be helpful if a largely EMA-driven model is going to be something that emergency managers are able to get their heads around and to be able to organize people to be able to support. For origination software, we're considering a few options. We're looking at maybe building a single, highly portable and self-contained program that will pull and originate messages while it's running. It could log the originated messages at a central server. For the processing software, we're looking at some options, thinking about maybe having something to show activity at the receiving station. Maybe we could just display a pretty version of the message rather than the XML markup version. Maybe we could play the same tones that would get created by that message type. Maybe we could have some user selectable sounds for events and fire up some kind of a siren or something if it happens to be a flash style message or a tornado alert or something along those lines. That should also automatically log in a way that would aid us in our reporting and keeping track of how long it takes to get messages all the way through. And of course, having logging software that's going to be able to work with these things is going to be much easier than the way it's done right now, which is just manually. We've got a spreadsheet that we're using to measure the latency and to compare against our quality of service goals. We should be able to take automatic reports from the originating stations and the delivering stations, put them together, and generate those reports at any time, and in fact, even in real time. So maybe you've got some ideas. What might make sense for Weather Alert Project 22? Should we be looking at other use cases rather than continuing down this path with weather specifically? Or maybe we should find some other good source of regular common alerting protocol messages and try to build something around that. Keep in mind, this is meant to be a system for highly resilient message relay to handle critical information when regular commercial infrastructure isn't working. We're not trying to rebuild or to replace the commercial internet. What we're looking to do is to get something that will allow for an alerting authority to get information to specific communities when they need that information most. That's what we've got going on with the Weather Alert Project. I'm very interested in your ideas. Please leave comments. Feel free to send me email. I look forward to hearing from you. Please like the video, share it with others, subscribe to the channel if you haven't already. I look forward to seeing you in a future video. This is Radio KD8TTE out.